Hey guys, this is a full review for exam one for college algebra. It's to prepare you to take exam one. Feel free to fast forward, scrub the video to the questions that you specifically need help on, and thank you for joining me. All right, question 1 and 2 are just about defining polynomials. These are called terms, okay? And a polynomial just means it has an amount of terms because poly just means many numbers, right? So they're asking you to identify if it is a monomial, a binomial, or a trinomial. By it, we mean this guy, 3x plus 6 plus 6x cubed. Give the degree of the polynomial and name the leading coefficient. Let's first talk about what a monomial is just mono means one, bi means two, and tri means three, right? Like wheels of a bike or a trike. And then, so monomial means there's one term, okay? The term is just the number or number and letters between each sign, between each addition or subtraction sign, okay? So we're counting the terms. This is a term, this is a term, and this is a term, okay? Give the degree is referencing an exponent. Give the degree of the polynomial and name the leading coefficient. So this is the one word that I think is important here is what is a coefficient? The coefficient is the number before or being multiplied to the variable. And the variable here is the letter x. Okay, so the coefficient is the number before the variable. That will be true for all of this class. That's what it always means. Good? All right. So they give us 3x plus 6 plus 6x cubed. We know if we need the degree of it and the leading coefficient, to lead just means the first one, right? So the leading coefficient right now is 3 because that is the number before the variable x. However, we want to put it in descending order. All right. So we're going to go from biggest exponent or biggest degree. We're going to go from biggest degree to smallest degree, okay? So the biggest degree is x cubed. There's a plus sign there, so that's not a negative 6x cubed, it's just 6x cubed. The next biggest degree is x because it's kind of like there's a 1 up there. That's x to the first power. Again, there's no minus sign in front of the 3x, so I'm just going to say plus 3x. And then we have plus 6. That is called a constant, and that is always at the end, right? You can kind of imagine that there is an x to the power of 0 there because anything to the power of 0 is 1. So it's kind of like 6 times 1 or x to the power of 0, x to the power of 1, x to the power of 3. Okay, now it's in descending order. Let's count them so that we know it is a trinomial because there are 1, 2, 3 tri, right? Tri means 3. There are 3 terms, so it's a trinomial with a degree 3. The degree is you're just copying the biggest exponent. The leading coefficient. Remember, a coefficient is the number before the variable, the first number before the variable. It's not the biggest, it's just the one in front of the variable with the biggest exponent is 6. Leading coefficient of 6, degree of 3, trinomial. Good? One more time. Here we have 2x squared plus 5x minus 6. The polynomial is a trinomial because we have 1, 2, 3 total terms. Trinomial. What is the degree? First, make sure you've put it in order, okay? Of descending exponents. 2x squared plus 5x minus 6 is descending order. So we have x squared, x to the power of 1, and then x to the power of 0. The highest degree is a 2. And then the leading coefficient is the number in front of the x squared, leading coefficient of 2. Good? All right. Question 3 asks us to multiply 2y plus 1 squared. Do not just take that squared and say, oh, that becomes 2y squared plus 1 squared. That will not work, okay? So don't just do that. Don't just distribute the exponent. There are some things we can distribute. The exponent is not something that we can distribute in this case, okay? Instead, we're going to say, what does squared mean? It means times itself, right? So if we had 9 squared, that would be 9 times 9, which would become 81, right? It just so happens that times itself was just one number. We're going to do this whole thing times itself, okay? So that's going to look like 2y plus 1 times 2y plus 1. Good? Now we're just going to FOIL. So FOIL means we take this term and we multiply it by this term. The 2y times the 2y, those are called first in FOIL. First is 2y times 2y. Good. The next letter of FOIL is O for outside. The outside terms are 2y times 1. Next letter is I for inside. So we're moving over to the 1. Inside terms are 1 times 2y. And then, I guess we do it in pencil. L. L just means last, so we're going to do 1 times 1. Okay, so we just FOILed it. First, outside, inside, last. Or you're just distributing the 2y to the 2y and the 1, and then you're distributing the 1 to the 2y and the 1. 2y times 2y, 2 times 2 is 4, y times y is y squared, okay? So that's 4y squared. The outside, 2y times 1 just remains 2y. 1 times 2y is a different order, but it's the same answer, 2y, and then 1 times 1 is just, 1 times 1 is just 1. So you're going to take all of that and combine them. They're all positive, so we're going to add them all. And it becomes 4y squared, don't forget the squared, the positive 2y, so plus 2y, positive 2y, plus 2y, positive 1, plus 1. Okay, now this is our answer. However, we can combine like terms, okay? So it remains 4y squared, 2y and 2y is 4y, and 1. Oops, got off the page. Good. So our final answer for what is 2y plus 1 squared, let's say 2y plus 1 quantity squared is 4y squared plus 4y plus 1. You're done. All right. That was multiply. Now they're asking us to factor. So they give us 2x to the third plus 50xy squared. And you need to factor out anything that is common to both terms. Remember, we have 2 terms, and we want to factor out anything common to both terms. So let's start with the numbers. We have the number 2 and the number 50, right? Is there anything that's common to both 2 and 50, meaning I can divide both 2 and 50 by that number? Yes, 2, right? So if I take 2x cubed plus 50xy squared, and I divide both of those by 2, I factor out the 2, okay? 2 divided by 2, well, I'm factoring out the 2, so I'm going to put it on the outside, okay? 2 divided by 2 leaves us with just the x cubed, plus 50 divided by 2 is 25, and then xy squared. So we factored out a 2 because we can divide 50 by 2 evenly to get 25, and we can divide 2 by 2 evenly to get 1. Good. There is one more thing we can factor out, all right? We can look at the x's. This is x to the third, and this is x, okay? What is common to both of those? 1x, right? Because if we imagine it, it's kind of like 2x times x times x plus 50 times x times y, right? That's what those exponents mean, is we're multiplying it by itself that many times. We get 2 of the y's multiplied by themselves. We get 3 of the x's multiplied by themselves. We already factored out the 2, but we can also see that there is a x of both of the terms that we can factor out. So we're going to factor out a 2x, okay? So that now becomes 2x is factored out. 2 divided by 2 becomes a 1, right? And we're not even going to write the 1. You can if you want. And then the x, 1x cancels, and we have 2 x's remaining. Good. 50 divided by 2, is that 25 again? It remains positive. The 25, this x cancels this x, and we get y squared. So my final answer is that I factored out 2x, and what remains is x squared plus 25y squared. All right, moving on to question 6. Sorry, question 5. Where did it go? Disappeared. Okay. Here it is on a different piece of paper. That was odd. Whatever. All right, here's question 5. Factor the following by taking out the greatest common factor. It's just a different way to ask that same question. Question 4 said factor completely. Question 5 says factor by taking out the greatest common factor, which is what we did here. The greatest common factor was 2x. Here, we need to find, again, the greatest common factor. 2a cubed minus 3a squared. I don't think we're going to be able to factor out a number, right? Because 2 and 3 don't have any common factors. And it's also a negative 3. I should remember that. But we have 2 times a times itself 3 times, right? Minus 3 and a times itself 2 times. What is common to both of those that we could take out? That both of them have nothing there. Both of them have 1a, both of them have 2 a's. This one has 3 a's, but we're looking for common, right? Common means both of them have it. It's 2 a's. Good? So that's the common factor. That common factor, I'm going to write it as a squared because a times a is a squared. So when I take out a squared, what happens? What am I left with? I have a squared, which is what I divided both of them by, and now I'm left with 2a minus 3. A squared times 2a minus 3. That's the greatest common factor. Just note that that remains a negative. All right, that was question 5. Question 6. Use factoring by grouping to factor the following. Factoring by grouping can take a long time, or a lot of steps, a lot of space, I should say, not time, but space. ay minus 3y minus 5a plus 15. When and why do we factor by grouping? We factor by grouping when we cannot find any common factors. So question 4 and question 5 were about common factors. If there are no common factors, you factor by grouping, okay? So we have 4 terms. None of them have a common factor, but we can split them into groups, okay? So my first group is ay minus 3y. Very important to note, my second group is negative 5a plus 15, okay? That sign always goes with the term, Good? Okay, so just looking at ay minus 3y, what is common to both ay and negative 3y? A y. So I'm going to factor out a y. Ay divided by y is just a. Negative 3y divided by y is a negative 3. Got that? Not really, because I'm not on the screen. It's true because ay minus 3y divided by y becomes y on the outside. Those cancel, and I have a. Those cancel, and I have negative 3. That's how I got it. Okay? Factored out the y, a minus 3. Now we're looking at negative 5a plus 15. Negative 5a plus 15. What can I divide out? Always, if this is negative, divide out a negative, okay? It won't work otherwise. So this is negative, so my first term is going to be a negative. I'm going to divide out a negative from both of them. 5 and 15, I can divide out a 5. A and no A, I can't divide out any letters, right? I just have the negative 5 to factor out. So I factored out a negative 5. Negative 5a divided by negative 5 is just a positive a. Positive 15 divided by negative 5. Positive 15 divided by negative 5 is a negative 3. 15 divided by negative 3 is negative 5. Yeah. 15 divided by negative 5 is negative 3. Good? So I have y times a minus 3 minus 5 times a minus 3. Okay? Now, this is just two terms, okay? This term is y times the quantity a minus 3 minus 5 times the quantity a minus 3. I can now factor out the a minus 3. A minus 3 is factored out of this one and leaves me with y when I factor out the a minus 3, and then negative 5 when I factor out the a minus 3. Here's better. So I had y times a minus 3 minus 5 times a minus 3. I'm going to factor out the a minus 3. Factor out the a minus 3. Remember, if I factor it out, I put it in the front, right? And then what do I have when I cancel that? I cancel the a minus 3, and all I have is y. I cancel the a minus 3, all I have is negative 5. Same answer. Okay, so our answer is a minus 3 quantity, a minus 3 times quantity y minus 5. A minus 3 times y minus 5. Good. Factor the trinomial. These also sometimes take a while. X squared minus 4x plus 3. Okay, remember the rule for factoring trinomials is you want to find two numbers. Well, let's hold on. We have ax squared plus bx plus c is the form it's in. Okay, so in this case, a is just 1, b is negative 4, and c is 3, right? A is 1, b is negative 4, c is 3. And what we want to find are two numbers who multiply to equal c times a and who add up to equal b. Okay? X squared minus 4x plus 3 is where I got these answers, right? 1x squared, negative 4x, 3. The c is 3, so we need it to multiply to equal 3 times, the a is just 1, thankfully, and we need it to add to equal negative 4, okay? So it should multiply to equal 3 add to equal -4. That is how we factor a trinomial. Think of numbers that multiply to equal 3 and add to equal -4. We have 1 and 3. It has to be a positive 3. Or we have -1 and -3, right? Those are basically our only options. Which ones of those add to -4? When we add those become +4. When we add these two, they become -4. So we like these two, okay? And when a equals 1, we can just put those in as our x values, or as the end of our equation, sorry. We can just put those in as x minus 3, x minus 1. Those are kind of how we find the two binomials that we're multiplying. So that factors to x minus 3 and x minus 1. It does not matter what order you write it in, okay? We can also check our answer. X times x is x squared. X times -1 is -x. -3 times x is -3x. -3 times -1 is +3. Simplify that to x squared minus 4x plus 3. Just make sure you have the same answer that you started with when you multiply them out again, okay? So that's how you factor a trinomial. Here's another one. X squared minus 3x minus 4. Ax squared plus bx plus c. So we know that in this case, a is 1, b is -3, c is -4, right? Sure. Okay. Good. So question number 8, x squared minus 3x minus 4, ax squared plus bx plus c means a is 1, b is -3, c is -4, right? We want two numbers that multiply to equal a times c and that add to equal b. So they multiply to equal 1 times -4, and they add to equal -3. 1 times -4 is they need to multiply to equal -4, and they need to add to equal -3, okay? There are a few more options for -4 than there were for our last example from question 7. What are the multiples of -4? We could say 1 and -4, and then because it's a negative, we can do the opposite of that, -1 and 4. So I made the opposite of 1, -1, the opposite of -4, +4. We can also do -2 and 2, okay? And then you could do the opposite of that. That would be a +2, and that would be a -2, but that would be the same numbers, really, right? Okay, I think those are all the factors, pairs for -4. Do any of them add to equal -3? -4 and 1 equals -3. -1 and 4 equals +3. That equals 0. Which one do we want? We want -3. Okay, so that just means we can switch it, change it to, or sorry, our final answer is x plus 1, x minus 4. You're also welcome to write it as x minus 4 times x plus 1. Good? X minus 4 times x plus 1. All right, question 9 is a little bit more difficult because, or could be, because our first term is not a 1. Okay? We have 8x squared minus 6x plus 1. It's always a good idea as well to make sure you don't have any common factors of these three. So is there anything you can divide out of this? Like if this was 8x squared minus 6x plus 4, you could divide out a 2, for example, okay? There's nothing we can divide out of here, but just to note. Okay, so A is 8, B is -6, and C is +1, right? So we need it to multiply to equal A times C, which I just skipped to 8 times 1, and we need to add to equal -6, or add to equal B, right? +8 times +1 is just 8, so it needs to multiply to equal 8, add to equal -6. What are the factors of +8? Well, you could say 1 and 8. You could also say -1 and -8 because a negative times a negative becomes a positive. You can say 2 and 4, and you can say -2 and -4. Any other numbers? So I started with 1. I could divide 8 by 1 and get 8. I could divide 8 by 2 and get 4. Can I divide 8 by 3? No. Can I divide 8 by 4? Yes, but we already have it. So these are all the factor pairs possible. Do any of them add to -6? 1 plus 8 is 9. -8 times, or sorry, plus -1 is -9. 2 and 4 is 6. -4 and -2 is -6. So we like this one. Okay. If I do with this what we've been doing with the other ones, where we just say x minus 6, sorry, where I just say my answers are -2 and -4, so I'm going to say x minus 2 times x minus 4. Will that work? I say it doesn't work if A is not 1. If A is not 1, this is not going to work. Why do I say that? Because you have x times x. X times x, when we multiply it back out, x times x is not going to give us 8x squared. It's just going to give us x squared. X times x is x squared. X times -4 is -4x. -2 times x is -2x. -2 times -4 is +8. So that's x squared minus 6x plus 8. That does not give us what we originally had. Kind of gives us backwards version of it, right? So if A is not equal to 1, we cannot do this step, all right? We know it's -2 and -4, but we're not finished. Now we have to factor by grouping, okay? So we take that -6x and we replace it with a -2x and a -4x. That's what we do when we find our our factor pair. We replace the middle term with that. So we keep that 8x squared, and instead of -6x, we say -4x minus 2x. So instead of -6x, I have -4x minus 2x. When I combine those, I still get -6, but now I can factor by grouping. It also does not matter if you put the -4 first or the -2 first. You can flip those. You will still get the correct answer after you factor by grouping. Okay? Let's look at this. There's no common factors to all 4 terms, but I can put them into 2 groups. 8x squared minus 4x and -2x plus 1. All right? 8x squared minus 4x. What can I divide both of those by? I can divide both of them by 4x. Because 8 divided by 4 is 2. X squared divided by x is x. So that becomes 4x on the outside. 8 divided by 4 is 2. X squared divided by x is x. -4x divided by 4x is just -1. Okay? The other one, -2x plus 1. -2x plus 1. Remember, if that's a negative, the term you're going to divide by is going to be a negative. So I'm just going to say it's -2 and 1. The only common factor is 1. And there's no common x. So I'm just going to divide both sides by -1. Put that on the outside. -2x divided by -1 is a +2x. 1 divided by -1 is a -1. Okay? So instead of 8x squared minus 4x minus 2x plus 1, I have that same term for A, 8 8x squared oh, sorry, 8x squared minus 4x minus 2x plus 1. I'm just going to rewrite it because what I was saying was not what I meant to say. This becomes 4x times the quantity 2x minus 1 minus 1 times the quantity 2x minus 1. So now I have two terms, right? We started with 3 terms. Then, where's another color? We started with 3 terms. Then we went to 4 terms. Now, if you look carefully at this, we have 2 terms, okay? From 3 terms, 8, -6, 1, to 4 terms, 8, -4, -2, 1, to 4, -1, 2 terms, okay? And then we factor out the 2x minus 1. So then we get 2x minus 1 factored out times, when I factor that out, I get 4x. When I factor that out, I get -1. 2x minus 1 times 4x minus 1 is our final answer. We'll put it right up there. Oh no. 2x minus 1, 4x minus 1. And let's make sure that multiplies out. 2x times 4x equals 8x squared. 2x minus 1 is -2x. -1 times 4x is -4x. And then -1 times -1 is +1. So now I have 8x squared minus 2x minus 4x plus 1, which is what we had when we factored by grouping. And then we simplify -2x minus 4x to 8x squared minus 6x plus 1. So we can get back to our original trinomial. That's how you would check your answer. All right. Factor the following as the difference of 2 squares. Be sure to factor completely. Okay, factor the following as the difference of 2 squares. Be sure to factor completely. I want you to see what I did. So what I did was typed into Google formula for the difference of 2 squares, in case you didn't have it already written down. And then I went to images, and it says a squared minus b squared equals a plus b quantity times a minus b. Okay, so I'm just going to write that down on a piece of paper. All right, so I'm just going to write that down on a piece of paper. And look at it. A squared minus b squared equals quantity a plus b times quantity a minus b. We have, and that's all you have to do, okay? You will be done when you can get it from a squared minus b squared to a plus b times a minus b. Good? So here we have 9u squared minus 25w squared. Let's look at this. They said a squared all right, that kind of looks like something that could be that. Minus, okay, minus, so that's not part of b, minus, and then they said b squared. Okay, that's kind of fitting, right? Because I have a squared, I like that. And I have 2 terms, and I have a minus between them, so that's a good sign, okay? All right, a squared is 9u squared. Can I say that? Those look the same to me. B squared is not negative 25w squared, it's just 25w squared because the negative is part of the equation, okay? So if I know that a squared is 9u squared and b squared equals 25w squared, I need to find, to finish this, I need to find what is a and what is b, right? If I have a, I'll just put it right there. If I have b, I'll put it right there, and then I'll just put a there again and b there again, and I'll be done, okay? What do we do if we have a squared, but we need to find a? We do the opposite of squaring something, which is to take the square root of it. Okay, we can do it to a and we can do it to b because if I take a squared and take the square root of it, it just becomes a. Let me show you. I like Desmos. Okay, so if I said the square root of 9 is 3, and then I said, but square that, it gives me 9, right? Because the square root of 9 was 3, and 3 squared is 9. So it doesn't even matter what order I put it in. Square root 9 squared is going to be itself. Okay? That's how we know we can cancel it. That it does cancel. All right? So the square root of a squared is just going to be a. The square root of b squared is just going to be b. So we're done with that side. We just have to take the square root of 9. What do you think the square root of 9 is? And you're welcome to use a calculator, right? We kind of just did it. What's the square root of 9? Oops. What's the square root of 9? It's 3. Good. So the square root of 9 becomes 3. The square root of u squared is u. Just like the square root of a squared is a, the square root of u squared is u. Here we got b squared becomes b because we took the square root. The square root of 25 is 5 because 5 times 5 is 25. And then the square root of w squared is w. So I now went from, I identified a squared, and then I found a. So a is 3u. I'm just going to write it again. And b is 5w because a squared is 9u squared and b squared is 25w squared. All we have to do now is put parentheses, a plus b, parentheses, open another set of parentheses, a minus b. All right, so my answer is going to be 3u plus 5w and then times 3u minus 5w. You're done. That is difference of 2 squares. Quite intimidating, but you're done. Good? Okay. Now we've got some division. I guess I should write that. 3u plus 5w, 3u minus 5w. Doesn't matter the order either. You could put the minus sign up here and the plus sign back there. Okay, now it's asking you to simplify a squared minus 16 divided by a squared minus 36 times a plus 6 divided by a minus 4. All right, to simplify, I would expand a squared minus 16. Hold on. Yeah. Okay, so I'm going to expand a squared minus 16 as much as I can. A squared minus 16. If I had to factor this binomial. It's not a trinomial, but it's a binomial, but it is factorable. Same rules, right? AX squared plus BX plus C. It's not an X, it's an A. No, but that doesn't really work. A squared plus BA plus C. Ugh. All right. That means my A is 6. Callie, no. My A is 1 and my C is -16. My B is, where is it? It's 0. Good. So we want a number that will multiply to equal -16, but add to equal 0. -16, 1 and -16, -1 and 16, 2 and -8, -2 and 8, 3, no, 4, 4 and -4. And that's all, right? Do any of those add up to 0? That adds up to a -15, that adds up to 15, that adds up to -6, that adds up to 6, and that adds up to 0. All right, so A squared minus 16 becomes factors to A plus 4 times A minus 4. Good? So A squared minus 16 becomes A plus 4 times A minus 4. And then we're just going to multiply it by A plus 6 times A plus 6, right? Because that multiplication just means it's an extension of the division bar, like that, okay? And on the bottom, we have A squared minus 36. We can do the same thing again. A squared minus 36. A is 1, B is 0, C is -36, right? So we want a number that will multiply to equal -36, add to equal 0. It's going to be -6 and +6, right? Because we need them to equal 0 when we add them together. So it has to be the same number, one being negative, one being positive, right? 6 times 6 is 36. So -6 times a +6 is a -36. Good. So that means it becomes A minus 6, A plus 6. A plus 6, A minus 6. It's all multiplication times, and we had A minus 4 already there, right? Okay, now what you want to do is cancel anything common to the top and the bottom. A plus 4 is one of the terms on the top. Is there an A plus 4 on the bottom? There is not. A minus 4 is a term on the top. Is there a term A plus 4 on the bottom? Yes. Good. And then we have A plus 6, and there's an A plus 6 on the bottom. So those all cancel, and what we are left with is A plus 4 on top, A minus 6 on the bottom. Okay, so the hardest part here, I think, is factoring the A squared minus 16 and the A squared minus 36. But we know, right, that because there's no B, because that's a 0, it has to be a number times itself, one negative, one positive, right? It had to be a +4 times a -4. So that had to be a +4 times a -4, so that I know is A plus 4, A minus 4. Here, it's a negative 36 and there's no b. So I know that has to be a plus 6, a minus 6. All right, so if you ever see one like this and you don't know what to do, you can just start squaring. Where's my calculator? You can just start squaring all the numbers, right? You can say 2 squared, or 2 times 2 is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. Oh, I found 16, right? 6 squared is 36. I found 36. So 36 is just going to be a positive 6 times a negative 6. 16 is going to be a negative 4 times a positive 4. That's the hardest part for question 11. Question 12 says use property 1 for radicals to simplify the following radical expression as much as possible. Assume all variables represent positive numbers. All right, so we have 294x to the third. I'm sorry, you couldn't see that. Use property 1 of radicals to simplify the following radical expression as much as possible. Assume all variables represent positive numbers. And we have the square root of 294 times y to the third. Okay, there are a variety of ways to do this. What I would do is I would have a list ready of all the perfect squares. Okay, so I would just go to, again, to Google. I would say perfect squares. That's not super easy to read. Give me that page. Oh, that's not easy to read either. Okay, chart. 1 to 30. All right, so we've got this. We've got, I'll just list them. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 225, 256. You can stop there because we have the number 294. So I'm going to take 294 and I'm going to divide it by each of these numbers, starting with the biggest one until I get a whole number answer, okay? It's a little bit silly to start with 256, but 294 divided by 256 does not give me a whole number. So I'm on 169. I don't think that's going to be a whole number. $49. Okay, so we know that 49 is 7 times 7. So the square root of 49 is 7. Okay, that's why we did that. So you find the list of perfect squares, or you make it with your calculator. And then you start with a number smaller than that one, but a big number, and then you just go down until you find a match. Because you want to find the biggest match possible, and then you're going to split 249 into the square root of 49 and square root of 6. Okay, and we're ignoring the y to the third. Sorry, I kind of just started where I started without explanation. So 249 is the same as 49 times 6. So 249 y cubed is the same as 49 times 6 times y cubed, right? And then we're going to take out the 49 and make it a 7 outside the radical. So that becomes 7 square root 6y to the third. Okay, 6, we can't divide 6 by 4, so we know that 6 is has to stay under the radical. You can't factor 6 any further. That will pull out a perfect square, right? So we have 6y to the third. Sorry, that 3 is not small enough. Now we go on to the variable because the variable is a little bit easier. So we have 7 square root 6y to the third, and I'm going to change that y to the third to 6 times y times y times y, because that's what they mean by y to the third, right? We're multiplying y by itself 3 times. And we know that any pair can come out. Okay, so now that those 2 y's become 1 y next to the 7. So our final answer is 7 times y square root 6y. Because I took the 249, sorry, I didn't write it right, 294. I'm supposed to start with 294, sorry. 294 divided by, just turned off. 294 divided by 49 is 6. So 294 becomes 49 times 6. The 49 comes out, becomes 7. The 6 stays under. We have the y to the third. Y times y comes out to be y outside. 7y square root 6y as our final answer. Good. All right, that's number 12. Number 13 asks us to write the following in terms of I and simplify as much as possible. So you should have a number out here, an I out here, and then if there's anything under the radical, okay? Remember that I is square root -1, right? So to get that I, square root -54 becomes square root -1 times a positive 54, right? Which is, and then that -1 comes out as I square root 54. Okay, don't be afraid of the I. The I is just, if that's a negative, change it to -1 times what you had, make that -1 an I, and you're done. You found the I, you're done. Now you just have the 54 under this perfect square, or sorry, under the square root symbol. And we're going to deal with that the same way we dealt with the 294 in question 12, right? We're going to look at our list of perfect squares. We have the number 54. And we're just going to divide these numbers by 54 by these numbers. 54 divided by 49, I don't think it's going to work. 54 divided by 36. 54 divided by 25. 54 divided by 16. 54 divided by 9. 6. Good. So currently it's I radical 54. We decided that 54 is going to become 9 times 6. And that 9 can come out as a 3. So now we have 3i. Square root 6. -54 is 3 times I square root 6, because 54 is 9 times 6. 9 becomes 3. 6 stays under. And the negative is the I. All right. Same rule. I is square root -1. True? Okay. I is the square root of -1. This is negative square root -45. So I'm going to say negative square root 45. I'm going to ignore this one, okay? Don't forget, I'm ignoring it. I'm not doing anything with it, okay? I took the rest of it and put it over here. Equals negative 1 times 45, which equals I 45, right? But I still have that negative, okay? We got rid of this negative became I, but we are ignoring this negative, okay? 45, again with our list of perfect squares. 45 divided by 36, 45 divided by 25, 45 divided by 19, 45 divided by 9, 45 divided by 4, 45 divided by 1. 45 divided by 36, I guess. 45 divided by 45 is 9 times 5. Good. So we keep that I on the outside. Square root 9 times 5, right? Besides ignoring that negative sign, we took square root negative 45, turned it into I square root 45, and we turned that into I square root 9 times 5. That 9 now comes out as a 3, so now I have 3I square root 5, okay? Just like we did up here, we got 3I square root 6. Here we got 3I square root 5, but we ignored that negative sign, so you say it's negative 3I square root 5. Okay? There's also a way to check this during the exam if you want to. So for this one, you can go, what is the square root of negative 45? Ugh. What's the square root of 45? And then you can say, what is 3 square root 5? And you can even do negative 45. Don't put the negative under, obviously. So whatever your answer is, you can make sure that it looks the same as what you started with when you put it into the calculator in terms of decimals. Good. Okay. Find the following product. Here we are just foiling. Okay, so treat that I like an X. It is nothing to worry about. So we have 4 times 4 minus I quantity 2 plus 4I. So we're just foiling 4 times 2. 4 times 2 is 8, not 6. We're not adding, we're multiplying. Outside numbers, we have 4 times 4I equals 16I. Inside, we have negative I times 2, so we get negative 2I. And then last, we get negative I times 4I, which is 4I squared, but with a negative. Good. So then we have 8 plus 16I minus 2I minus 4I squared. Good. Let's combine like terms. 16 minus 2, 14 equals 8 plus 14I negative minus 4I squared. We are not done because 4I squared, we can take that I squared and turn it into a negative 1. Okay? So those are the two rules about I. I is equal to the square root of negative 1. And if that is true, if I square them both, then I equals negative 1. Sorry, I squared equals negative 1. Good. So we have 8 plus 14I minus 4I squared, but we're going to take that I squared and call it negative 1. So we're going to replace it with negative 1. So it's 8 plus 14i minus 4 times -1. 8 plus 14i plus 4, because the -4 times the -1 is a +4. 8 and 4 are now like terms. So now I have 12 plus 14i. There's my final answer. Sorry, it's all diagonal. Okay. Hold on, I'm going to stop this for a while. All right, question 18 is moving into scientific notation. What you want to remember about scientific notation is that you want one number that is not 0 in front of the decimal, okay? Here, we have the distance around the Earth at the equator is more than, and then a really big number, feet. Write this number in scientific notation. 130 million? All right, so we have the decimal point. We can just add it, right? The decimal point's always at the end if you can't see it. And then what number do we want? We want the number 1.3 because we want one number in front of the decimal, right? So to get from 130 million to 1.3, how many times did I have to move that decimal point? So I jump it 1 time to get it to here, 2, 3. So at 3, it's now at 130,000. 4, 5, 6, 7, 8. So I moved that decimal point 8 times. Let's just make sure. 1, 2, 3, 4, 5, 6, 7, 8. Right? So it's going to be 1.3 times 10 to the 8th. Should that 8, our next question is, should that 8 be a -8 or a +8? You are always welcome to use Desmos during exams. So let me share my screen with my Desmos. Clear. All right. The options were 1.3 times 10 to the 8th or 1.3 times 10 to the power of -8, right? Oh, I wish they would show it. All right. -2 is going to give me a decimal. All right. So if your exponent is a negative, you're multiplying it by a small number. If your exponent is positive, you're multiplying it by a really big number. Okay. So if you want 1.3 to get bigger, you keep that exponent with a 10, a positive exponent. If you want that 1.3 to get even smaller, to go to the right of the decimal, to go behind the decimal, you make that exponent with a 10 a negative, because let's look at this. What is 10 to the power of 8? Oops. Gosh, dang it. What is 10 to the power of 8? It's a really big number. What is 10 to the power of -8? Dang it, come on. How far will it let me go? Only to 3? Really small number. Okay. So if you're changing a big number to a small number, you're going to multiply it by 10 to the power of a positive exponent. And so that's the first thing to understand about exponents is you should only have one number in front of the decimal point, and you have to have one number in front of the decimal point. The other thing to remember is that if this is a +8, if this is a positive exponent, it's going to be a really big number. If that's a negative exponent, it's going to be a really small number. Good? All right, for example, number 17 asks us to rewrite a smaller number in scientific notation. Again, we have 0.000356. We want one number in front of the decimal, 3.56 times 10, right? Because that's always a part of scientific notation. And then how many times do we move the decimal? 1, 2, 3, don't stop, don't just count the zeros and say, oh, there's 3 zeros, it's -3, because you have to go one past that zero, right? You have to keep going because we're not going to say 0.356. We're going to say 3.56. So we'll go one more. All right, let's count those. We have 1, 2, 3, 4 times 10 to the -4. Good. All right. If you earned, for question 18, if you earn $16 an hour and work full-time for 21 years, you will make at least 6.98 times 10 to the power of $5. What is this number in standard form? I would honestly just encourage you to use your calculator, or no. Why? Hold on. Mouse off. Connect. Sorry, my mouse lost Bluetooth connection. All right, I would just encourage you to use your calculator. So the question was 6.98 times 10 to the power of 5. $698,000. That's all I would do. Or if you wanted to do it by hand, 6.98. That is a 5. It's a positive 5. So positive 5 means the number is going to get bigger, right? 10 times itself 5 times is a really big number, and then we're going to multiply that by 6. So we'll move that decimal point. Remember, it's not right here, it's right here. Move that decimal point 5 places behind it so the number gets bigger. If we move it that way, the number gets smaller. Move it that way, the number gets bigger. 1, 2, 3, 4, 5. Here's our decimal place. Each of these needs a 0. And that's exactly what our calculator showed us too. $698,000. Question 19 says, I can't tell what it says, but I'm assuming it's just asking us to write this in standard form. 6.1 times 10 to the -5th, 6.1, 10 to the -5th. Again, head over to your calculator. 10 to the power of negative, oops. I backspace 1 too far. 10 to the power of -5. Come on, show me what it really is. It's that as a fraction. It's a really small number. I can do it on my calculator. 10 to the power of -5. -5 means we're making it smaller, so we're going to move 5 in this direction. 1, 2, 3, 4, 5. Okay, that's where my decimal point goes. Put a 0 in front of it. Okay, that's where my decimal point goes. So I need to have all of this behind the decimal, and then I can put a 0 in front of it. So we have, it ends with 6 and a 1. For that we have this, 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 right? I'm filling in the blanks. Was that 5? Did I move it 5? 1, 2, 3, 4, 5. I moved it 5 places, and my answer is 0.000061. Let's see if this redeems itself, this system. 0.000061. Will you put it into scientific? No. Fine. All right, find the product, enter your answer in scientific notation. You're welcome to just throw all of this into a calculator. 7.2 times 10 to the power of 3 times 3 times 10 to the power of -8. No. So that would be 2.16 times 10 to the -4th. Or, okay, what you can do is you can multiply them separately. So you can take 7.2 and multiply it by 3 in your calculator. $21.6. Right? And then you can say we have 10 to the third times 10 to the -8. Okay, and what are the rules for exponents for that? 10 to the third times 10 to the -8 equals, when you're multiplying and they have the same base, you can add them together. So that'll be 10 because the base remains 10, and then we have 3 plus -8, or 3 minus 8, which is 10 to the -5th. Okay, so when I put those two parts together, here, 10 to the -5th, because I combined 10 to the -3rd and 10 to the -8th, 21.6 because I multiplied 7.2 times 3. So I multiplied these two to get this. I multiplied these two to get this, right? Now I can put them together as 21.6 times 10 to the -5th, right? What does my answer say? 2.16 times 10 to the -4th. How are those different? Those are different because that's supposed to be a decimal point, that's supposed to be multiplication. Those are different because I can't, 21 is not in scientific notation, unfortunately. Okay? 21.6 times 10 to the -5th will give me that same answer, right? But what this calculator is showing me is that this is not in scientific notation. Why? Because for scientific notation, you may only have one number in front of the decimal. This has the 2 and the 1 in front of the decimal. So what we need to do is take 21.6 and we need to turn it into scientific notation. To do that, it'll be 2.16. And how many places did I move it? Get from here to here, I moved it one place. So we're going to say 2.16 times 10. Did I make 21 bigger or smaller? I made it smaller, so that's times 10 to the -1. So this 21.6 becomes 2.16 times 10 to the -1 times 10 to the -5th. Okay? Now, just like we did here, we combine them by adding them. Keep 2.16 the same, times 10. -1 plus -5 is 2.16 times 10 to the -6, which is what my oh, sorry. I made it smaller. Oh, I made it smaller, so it should be a +1. I apologize. Oh my gosh. Goodness gracious. Good thing for calculators, right? Hopefully you guys caught that before me, but if not, so we're going from 2.16 to 21.6. So we need to multiply it by 10. Oh, I'm so sorry. That's already super confusing and I said the wrong thing. So our answer is 2.16 times 10 to the -4th. Good? Okay. All right, and I know you guys don't all have these scientific calculators, but you do have the Desmos scientific calculator. You don't all have the graphing calculator I'm using, but you do have the Desmos calculator. And when I just put in exactly what XYZ gave me, right? The answer they gave me was 2.6 times 10 to the negative fourth, which is the correct answer. Okay, so you're welcome, welcome, welcome to do that anytime. Our next question is 2.1 times 10 to the fourth times 4.4 times 10 to the eighth. This is for question 21. And it's going to give us 9.24 times 10 to the 12th. Another way to do it, same way, multiply 2.1 times 4.4, 2.1 times 4.4, (9.24). Okay. And that's good because that's already in scientific notation. That's easier, right? And then we have 10.4 times 10 to the power of 4 times 10 to the power of 8. And remember, when the bases are the same, we add them. 4 plus 8 equals 9.24 times 10 to the power of 12. Let's just confirm that that is also what the Desmos gave us, and it is 9.24 times 10 to the 12. Good? All right. Find this quotient, enter your answer in scientific notation. Again, you're doing the same thing, okay? You're taking your, well, first of all, you're welcome to do it in Desmos, but you're taking your left side and you're saying 4.8 divided by 4. 4.8 divided by 4. Make sure, 1.2. Yay. 1.2. And then for this side, we have 10 to the power of 17 divided by 10 to the power of 4. Using the rules of exponents, if the base is the same and you're dividing them, you can say the top number minus the bottom number. So that would be 10 to the 13th, right? So our final answer is 1.2 times 10 to the power of 13. Good. We'll go back to Desmos, make sure that's what they say it is too. 4.8 times 1.2 times 10 to the power of 13. Exact same answer, okay? Find this quotient, enter your answer in scientific notation. We have 7.2 divided by 4, which gives us 1.8. And then here we have 10 to the power of 12 divided by 10 to the power of 10. Remember, if the bases are the same, you can subtract the exponents for quotients for division, minus -3. Notice that it's minus a negative, so that's going to be add, right? So that becomes 1.8 times 10 to the power of 12 plus 3, which is 1.8 times 10 to the 15th. Good? All right. Make the following conversion in the metric system by multiplying the appropriate conversion factor and write as a whole number or decimal. Okay, so to get from centimeters to millimeters, what's the difference? 1 centimeter is 10 millimeters, right? So to get from 1 centimeter into millimeters, I multiply by 10. So if I have 36 of these, I need to say 10 times whatever my centimeters were for millimeters. So 36 centimeters equals 360 millimeters. Good. Oh no, I can't even read this one. All right, 7,485 centimeters to meters. To convert between meters and centimeters, we are going to divide the centimeters by 100, right? Or move the decimal 2 places. The decimal is here, we're gonna move it right there. So it's 74.85 meters. 4,683 milligrams to grams. Milli means it's 1,000th of a gram, right? So 1,000th of a gram. 1,000th of a gram into grams, we divide by 1,000. So we get 4.683 grams is equal to 4,683 milligrams. 8 meters to yards. Okay. 8 meters to yards. A yard is 3 feet, right? 1 meter is 3.28 feet. 8 meters times 3.28 will give us our answer in feet, right? 8 times 3.28 is 26.24. But that's not yards, that's feet. So we're having to do 2 different translations here. 26.24 feet. And then how many feet are in a yard? 3 feet in each yard. So we're going to take 26.24 feet divided by 3 to get yards. 8.75. I'm going to round that to 7.5. Why would I round it to 7.5? Because if that is 5 or bigger, that becomes 1 greater. It's closer to 5 than to 4 if there's 60% behind it, right? 40, sorry, here's a better way to say it. 46 is closer to 50 than it is to 40, so we're going to call it 50. 8.750. Okay. 60 gallons to liters. All right, first thing to know is that there are, so 60 gallons into liters, but we know that 1.06 quarts is 1 liter. But we don't see quarts here, right? We just see gallons and liters, 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 liters. Quart, there are 4 quarts in a gallon. Okay, we have 60 gallons. We can convert quarts to liters, but first we need to convert gallons to quarts. 60 gallons into quarts, we'll multiply it by 4. 240. 240. So there are 240 quarts in 60 gallons. And there is 1.06 quarts in a liter. To get from quarts to liters, it says 1.06 quarts in 1 liter. So we are going to take the quarts, the 240. And we're going to divide that volume, that amount, by 1.06. 240 divided by 1.06. 226.4 liters. All right. Okay. Solve for y in negative 5y plus 5 equals negative 4y minus 5. Okay, we know how to solve for a variable. The difference, or the most challenging part of this problem, is that we have a variable on both sides of the equal sign. Okay, so we can't, if there were no equal sign, we could just combine the like terms, right? But then we wouldn't be able to solve for y. Anyway, if both of the y's were on the same side, we could combine like terms and then isolate the y, right? But we have a y over here and a y over here. Instead, we want to cancel either the negative 4y or the negative 5y. We need to cancel it so that all of the y's are on one side. I like having the y's on the left side, or sorry, I like having the variables on the left side. I also like the variables being positive numbers. So you're welcome to do it either way. If you like your y's being positive, move the negative 5. If you like your y's on the left, move the negative 4, okay? But first step is get more space. So copy it over here. Negative 5y plus 5 equals negative 4y minus 5. First step is to combine the y's, right? So to cancel, I'm going to cancel this negative 4y by doing the opposite, right? Anything I do to this side, I have to do to this side. I'm going to put it right below the 5y because those are like terms. Negative 5y plus 4y leaves me with negative 1y, which you can also just write as negative y, plus 5 equals negative 5. Good. Now I'm going to cancel that positive 5. Because I want, why am I doing that? Because I want my y alone on the left side of the equal sign, okay? So right now, y is being multiplied by negative 1, and then 5 is being added to it. So you want to do the opposite of both of those. You want to divide it by negative 1, and you want to subtract 5 from it, and you want to do it in reverse PEMDAS order. So you want to do the addition subtraction first. So 5 is being added to y. I'm going to subtract 5 from y. Anything I do to this side, I have to do to this side. So now I have negative 1y. Those are gone. Equals negative 5 minus 5 is a negative 10. Finally, y is being multiplied by negative 1. To undo that, I'm going to divide by negative 1. Anything I do to the left, I have to do to the right. Y equals negative 10 divided by negative 1 is 10. So I got y equals 10. All right. I can also, like I said, if you like positive numbers more than you like the left side, that is perfectly fine. You will get the same answer. So I want to cancel the negative 5y by adding 5y. Anything I do to the left, I have to do to the right. So now that's a positive 5 equals negative 4 plus 5 is a positive 1y minus 5. Now I want my y alone. So I'm going to cancel the negative 5 by adding 5. Anything I do to one side, I have to do to the other. Y equals 10. You get the same answer. Good. My answer for that one is y equals 10. And we'll go on to question 30. If I could see it. All right, it's the same explanation as 32, so I'll just read 32. Solve the equation by first finding the least common denominator for the fractions in the equation and then multiplying both sides of the equations by it. But we're starting with 2x minus 1/6 equals 1/3. the least common denominator of these fractions, I just turned it into a fraction if you want. The least common denominator of these fractions is something that both 6 and 3 is a divisor of. So I can multiply 6 by a number to get the LCD, and I can multiply 3 by a number to get that LCD. Okay? The least common denominator is I can take that number, I can take the LCD, I can divide it by 6, and I can take that LCD and I can divide it by 3. What number can I divide by both 6 and 3 and get a whole number? The number 6, right? So that's, if you don't like fractions, that's a good way to get rid of fractions, is say, okay, 6. That's the biggest one. I'm just going to multiply everything by 6. Okay, so I'm going to take all of these. Let me rewrite it. 2x minus 1/6 equals 1/3. I'm going to take all of this. I don't like fractions. I don't like fractions. So this is being divided by 6, right? 1 is being divided by 6. So I'm going to take this and I'm going to multiply by 6, and that'll be gone. Anything I do to that term, I have to do to this term, and I have to do to this term. So everything in there just got multiplied by 6. 2x times 6 becomes 12x minus, right? That just stays. 1/6 times 6. You are welcome to do it with your calculator or in Desmos. 1/6. No. Goodness me. 1/6 times 6 is 1. They cancel out, right? That's a 6 on top of the fraction and on the bottom of the fraction. So that just becomes 1 equals 1 divided by 3 times 6. 1 divided by 3 times 6. 2. Good? Because it's kind of like saying 2x over 1 times 6 minus 1 times 6 over 6 equals 1 times 6 over 3. But how did that turn into 2? Because 1 times 6 is also 1 times 3 times 2 over 3. Cancel out the 3's, right? 1 times 6 over 3 is 1 times 3 times 2 divided by 3, or 1 times 2 times 3. Or it's just 6 divided by 3 is 2. Good? Okay. So solve the equation. So we first found the least common denominator was 6. Now we multiply both sides of the equation by it, and then I guess we have to solve for x, right? Because it's asking us for x equals. But it's a little bit easier now, right? Because the fraction's gone. So we have 12x minus 1 equals 2. We'll do the opposite of minus 1 is plus 1. Do it to both sides. 12x equals 3. Divide by 12. Divide by 12. X equals 3 divided by 12. Let's look at this. 3 divided by what's 12? 12 is 3 times 4. Cancel those, and you can say it's 1/4. 12, I put into its, I didn't put it into prime factorization, but I factored it so that I could cancel out the 3's. When nothing is on top, you don't put a 0, you just put a 1. So 3 over 12 is 1/4. Good. Okay, something else helpful with Desmos is that if you were to put 3 over 12 into Desmos, and then you hit this convert to a fraction button, it'll give you that fraction in its simplest form. All right. Question 31, solve for x when we have 3 times the quantity x plus 5 minus 5 times the quantity x plus 3 equals 2. Good? All right, let's copy this down just in case we need extra space for it. Should have put my camera at the side angle so I can write sideways. All right, we want to solve for x. The first thing we're going to have to do is distribute this 3 to the x and the 5, then distribute that -5. Note that that's a -5, okay? I'm going to distribute that -5 to the x and to that 3. Then we'll combine like terms. Then we'll keep the x on the left side and the constants on the right side. Move them over to the right side. Then we'll divide by whatever x is being multiplied by. Sound good? All right, so first let's distribute that 3. 3 times x is 3x. 3 times 5 is 15. There's a plus in between them, so it's positive. Positive 3 times positive 5 is positive 15. Positive 3 times positive x is 3x. Now we have that -5 times x is a -5x. -5 times a positive 3 is a -15. Good? Equals 2. Now we just combine like terms. We have 3x and -5x. Make sure you keep that sign with the number. And then we can combine plus 15 and minus 15. Good? So 3x minus 5x plus 15 minus 15. Well, plus 15 minus 15 will be easy, right? That becomes 3x minus 5x is a -2x equals 2 because positive and -15 cancel out to 0. X is being multiplied by -2. To undo that, we divide it by -2. Don't forget the negative. And we get x equals -1 because positive 2 divided by -2 gives us -1. Good? All right. Question 32 is the same as question 30. However, it's a little bit more difficult because with 30, we had 6 and 3, so we only needed to multiply everything by 6 to clear out the 3 as well. Here we have our denominators of 6 and 4. So if you want to find an LCD for 6 and 4, you kind of want to think about what are the multiples of 4 and what are the multiples of 6. So the multiples of 6 are 6, so we're getting bigger than 6. 6 times 1 is 6, 6 times 2 is 12, 6 times 3 is 18, 6 times 4 is 24. We will definitely find it by then, right? Because that's 6 times 4, right? The multiples of 4 are 4. 4 times 2 is 8. 4 times 3 is 12. 4 times 4 is 16. 4 times 5 is 20. 4 times 6 is 24. Good? All right, so we know that 24 is a factor or denominator because it is just 6 times 4. But there's an even smaller one in 12, okay? So because I can take 12 and I can divide it by 6, and I can take 12 and I can divide it by 4, it's called the least common denominator. That means if I want to, the easiest way to get rid of these fractions is to multiply this by 12, multiply this by 12, and multiply this by 12. It will get rid of everything at once. You could also multiply it by 24. That will get rid of it. It'll just give you bigger numbers, right? Because 24 is a bigger number. You can also just multiply everything by 6 to get rid of that one, and then multiply everything by 4 to get rid of these two. But that takes longer and again gives you bigger numbers because you've multiplied by both 6 and 4. So if you want to make the list, find a common denominator. That will be it takes a while, but it's the least likely for mistakes. And it's the smallest numbers you'll have to work with, if that makes sense. So we found our least common denominator of 12. And we're going to take x divided by 6 plus 3 divided by 4 equals -5 divided by 4. And we're going to multiply each of these by our least common denominator, just like we did for question 30. So we're going to multiply it by 12. Multiply 3/4 by 12, multiply -5/4 by 12. You can even leave the negative outside and just multiply it by 5 and 4 and then bring the negative bit back in. Anyway, all right. So that becomes 12x over 6 plus 3 times 12 over 4 equals -5. Well, let's just leave the negative out here. Times 12 over 4. Put the negative wherever you want. It's least confusing if you had left it outside the parentheses. Good? All right. Now you can just simply, what is 12 divided by 6? It's 2. We still have that x, so make sure you bring down the x. 3 times 12 divided by 4. That's 9. And here we have negative, right? So that stays, that stays. The x stays, the plus stays, the negative stays. 5 times 12 divided by 4. 15. -15. Good? And the reason for that is because 12 is actually 6 times 2 times x over 6 plus 3 is 3 times 3 times 4, right? 12 is 3 times 4 over 4. And then 5 times 3 times 4 over 4. And then you cancel out things that are common to the top and the bottom. The 6's cancel here, the 4's cancel here, and the 4's cancel here. And what you get is 2x plus 3 times 3 is 9 equals 5 times 3 is 15. Oops, I forgot the negative. Good? So you get the same answer. That's just how I did it without the calculator. All right, now you have 2x plus 9 equals -15. All I need to do is get the x alone. Right now it's being multiplied by 2 and 9 is being added to it. So we're going to subtract 9 from it. Anything I do to the left, I do to the right. So now I have 2x equals -15 minus 9 is -24 because we're just adding two negative numbers. Divide both sides by 2 because x is being multiplied by 2. X equals -12. Good. What was 31? 31 was -1. I stopped writing my answers down. I think this one was 1/4, right? Okay. 3x minus 2y equals 6 for y. Solve that for y. Three x minus 2y equals 6. Solve it for y. You don't need one number. You can have a whole equation, okay? So we're solving for y. We want y alone. Right now, y is being multiplied by -2 and added to 3x. I'm going to undo both of those things. I always undo addition and subtraction first. So adding 3x means I'm going to subtract 3x. Anything I do to the left, I should do to the right. Should not have put it under the 6 because those aren't like terms. Those cancel and I get -2y equals 6 minus 3x. You can also call it -2y equals -3x plus 6. Now y is being multiplied by a -2. To undo that, we're just going to divide by a -2. Anything I do to the left, I have to do to the right. Those cancel and I get y equals 6 divided by -2. You could say plus -3x divided by -2 if you wanted to cancel out the 2's. Or sorry, cancel out a negative number divided by another negative number becomes positive. So that's why I would put the negative with the 3 so that it could cancel. y equals 6 divided by negative 2 is 3 times 2 divided by negative 1 times 2 plus negative 3x divided by negative 2. We see that the 2's cancel, right? 3 divided by negative 1 is just negative 3. You can also just put 6 divided by negative 2 into your calculator and it'll give you negative 3. And then plus 3x over 2, because a negative 3 divided by negative 2 is just 3/2. So my final answer is y equals 3/2 x minus 3. 3/2 x minus 3. So that's that part. The x on the top of the fraction is the same as the x next to it. It both mean multiply by x, right? And then we have the positive 3/2. Good? All right. So that was 3/2 x minus 3. Good? All right, solve the following for the indicated variable. A equals P plus PRT for T. How would we solve A equals P plus PRT for T? It sounds and looks very confusing, right? There are no numbers. A equals P plus P times R times T, and we want to solve it for T, right? T right now is being multiplied by R, being multiplied by P, and P is being added to it. I just want to undo all of that so T is alone on the right side, okay? P is being added to it, I'm going to subtract P. Anything I do to this side, I have to do to this side. So I'm going to rewrite that as A minus P equals, those cancel, P times R times T. Right? Now T is being multiplied by RP. I'm even going to write it as A minus P equals T times PR. Okay, so I can do them both at once. It's being multiplied by PR. How do I get rid of multiplication by PR? Divide by PR. Anything I do to the left side, the right side, I have to do to the left side. Now that means I have A minus P divided by P times R equals T, because I canceled it. Good? Sounds very confusing. I would just take it one step at a time. Do the best. Do the best you can. All right, 35. This equation is already in factored form. Use the zero factor property to set each of the factors equal to 0. Okay? Sounds scary because they're using terms like the zero factor property, setting the factors. What is a factor, right? A factor is just something that you multiply together to get your answer. So if I multiply this factor, and this factor, I get 0, right? For example, the factors, like if I have the number 20, I can say it's 4 times 5. 4 is a factor of 20, 5 is a factor of 20. When I multiply my factors together, I get my answer. Okay, that's what I mean by factor. Using the zero factor property, set each of the factors equal to 0. Equal to 0. Equal to 0, right? The whole thing, all three of them together, is equal to 0. Set each of the factors equal to 0. We know what equal to 0 is. How many factors do we have? We have 1. More highlighters. Is that a pink one? Two, slightly different. Yay. 2 and 3. We have 3 factors, set them equal to 0, okay? This is just an overwhelming language, but if we break it down, we know what to do, okay? The equation just means it has an equal sign. The equation is in factored form. because it has factors. In factored form means it has factors, right? How many factors does it have? It has the blue factor, the pink factor, and the green factor. The following equation is already in factored form. That's true because there's a multiplication sign between each of the parts. If there's a multiplication sign between each part, those are the factors, right? And we've looked at factors this whole time. We made factors here, right? Here are some factors. Oops, sorry. Here are some factors, all right? That's what they mean by factors. The equation is in factored form. This is in factored form. This is not in factored form. That's what they mean, okay? The following equation, because it has an equal sign, is in factored form because there are 3 parts that are all each being multiplied, right? Use the zero factor property. All the zero factor property says is, the zero factor property says if A times B equals 0, then A equals 0 or B equals 0. That's the zero factor property. Good. So use that rule to set each of the factors equal to 0. This is a factor, this is a factor, and this is a factor. Set that factor equal to 0. Set that factor equal to 0. Set that factor equal to 0. Mixing up my colors. Darn it. What do I do now? Good. That's that factor, that's that factor, and that's that factor. We set them all equal to 0. Now solve for R. Okay? R equals 0. Done. R equals 0. Good. R minus 1 equals 0. Solve for R. How do I get R alone? I add 1. Anything I do to the left, I also do the right. R equals 1. Last one is R minus 8 equals 0. How do I solve for R? Get R alone, add 8 to this side, add 8 to this side. R equals 8. Good. So set each of the factors equal to 0. If you know what a factor is just what is between the multiplication signs, right? Factor, factor, factor. Set it equal to 0. R equals 0 gives us the answer of R equals 0. R minus 1 equals 0 gives us the answer of R is 1. R minus 8 equals 0 gives us the answer of R is 8. Why? Because if we put it back, right, we found R equals 8. That means 8 minus 8 equals 0. All right, I put that 8 in for R, and that is true. Here, R is 1, so instead of this R, I have 1 minus 1 equals 0. True. And this we just said R equals 0, so R equals 0. 0 equals 0 is also true. Good. So that's how you found those 3 answers. Question 36, solve the equation. So very similar to factoring the trinomial, except that after you have your 2 factors, you set you set your factor equal to 0, and then you find out what x is. All right, so sorry, gosh, I hate when I'm talking and then you can't even see what I'm doing with my hands. So factor the trinomial, solve the equation. Solve the equation just means once you have the factors, set each factor equal to 0, like we did up here, to find the answer. X minus 1 equals 0, X is 1. Good? Okay, so we're gonna do these ones just like we did at the very beginning of this video. Ax squared plus bx plus c. So we have x squared minus x minus 30 equals 0. You can kind of ignore the equals 0 part. Ax squared plus bx plus c means that our a is 1, b is -1, and c is -30, right? We need a number that multiplies to equal a times c and adds to equal b. A is 1, c is -30, so it needs to multiply to equal 1 times -30, or multiply to equal -30, and add to equal -1. Good? Let's just list the factors of -30. 1 and -30, -1 and +30, 2 and 15, sorry, 2 and -15, -2 and +15, 3 and -10, -3 and +10. Can I divide 30 by 4? I do not think so. Can I divide 30 by 5? Yeah, I get 5 and -6, or -5 and 6. I think those are all my factors because after that I have 6, and 6 is already on my list, right? All right, which one of these adds to -1? That would add to -29, +29, -13, +13, -7, +7, -1, right? 5 plus -6 is -1. So x squared minus x minus 30 equals 0 becomes x plus 5 times x minus 6 equals 0. Then we set each of those equals to 0, X plus 5 equals 0. Subtract 5 from both sides. X is -5. X minus 6 equals 0. Add 6 to both sides. X equals 6. Good. So my two answers are -5 and 6. Or 6 and -5. All right, then it says solve for a in a squared plus a minus 2 equals 0. Same exact thing we're doing here, okay? A squared plus a minus 2 equals 0. Ax squared plus bx plus c. So our a is 1, b is 1, c is -2, right? 1, 1, -2. Multiply to equal -2, add to equal 1, right? Because -2 times 1 is -2. What are the factors of -2? We either have -1 and 2, or we have 1 and -2. Which one of those adds to 1? -1 times 2, right? So this becomes a squared plus a minus 2 equals 0 becomes a minus 1 times a plus 2 equals 0. Set those equal to 0. A minus 1 equals 0. Add 1. A is 1. A plus 2 equals 0. Subtract 2 from both sides. A equals -2. So my answers are -2 and 1. Good. 4x squared minus 20 equals 0. Okay, when when we are solving, something like this, we always want to look and see if, because here we've solved it by factoring, right? This was the factored form. So if we look at 4x squared minus 20 equals 0, can we factor anything out of 4x squared minus 20? Four x squared minus 20, I can divide both of those by 4, right? So I can factor out of 4. 4x squared minus divided by 4 is just x squared. And then negative 20 divided by 4 is a negative 5, right? So instead of 4x squared minus 20 equals 0, I'm going to say 4 times x squared minus 5 equals 0. Now I have two factors. 4 equals 0. Well, that's not true. So that's not going to give me an answer. There's no x in there. X squared minus 5 equals 0. This is a hard one, but we can do it, okay? X is being multiplied by itself, and then 5 is being subtracted from it. What should I do? I should add 5 to both sides. Anything I do to the left, I should do to the right so that I can get x alone. Now I have x squared equals 5. Now, what should I do? Surprise. We're going to take the square root of x squared because that cancels the square, okay? The square root of x squared is x, and then the square root of 5, but anytime you take the square root, you have to say plus or minus, the positive or negative of the square root of 5. So x equals square root of 5 and negative square root of 5. That was a hard one. You're also welcome to use the quadratic formula or any other formula you prefer to solve these. I'm just doing it whatever way comes to me, I guess. All right. Now x squared plus 2x plus 1 equals negative 12. X squared plus 2x plus 1 equals negative 12. I say that because it kind of makes, this one kind of makes me want to use the quadratic formula. Just because they're giving me that kind of space for my answer. I'm like, oh, it's probably not factored form, right? Okay. So the first thing you want to do when you have a trinomial with x squared x and like ax squared plus bx plus c is you want to set it equal to 0. This isn't equal to 0, so we'll just move that 12. Right now it's minus 12, so we'll just add 12 to both sides so that it is set equal to 0. First step, right? X squared plus 2x plus 13 equals 0. Now you're welcome to try to factor it, but based on this, I don't think it's factorable, and the 13 isn't great, right? It would either be 1 times 13 or negative 1 times negative 13, and neither of those add to 2. So we, I guess, have to do the quadratic formula. And the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. Right? Okay, so we know a is 1, b is 2, and c is 13, remember, because we're using that one, okay? All right, so using the quadratic formula, x equals negative 2 plus or minus the square root of negative 2, positive 2, sorry. It's negative here. 2 squared minus 4 times 1, you can write it or not, times 13. All over 2 times 1. Good. Now we'll just simplify this. X equals negative 2 plus or minus the square root of 2 squared is 4. 4 times 1 times 13. I guess it's negative 4 times 1 times 13. 4 times 13 is 52. So 4 minus 52 divided by 2, right? That look right? Okay. X equals negative 2 plus or minus the square root of 4 minus 32. 4 minus 52 is negative 48. All divided by 2. Now, what do we do with a negative 48 under the radical? The negative under the radical, we're going to change to an I. Okay? X equals negative 2 plus or minus. I'm just going to take that negative 48 and put it up here. Negative 48. To get rid of that negative sign, I'm going to say that that is equal to negative 1 times a positive 48, right? A negative 1 under the radical becomes an I outside the radical. I times square root 48, okay? After that, you want to take that list of perfect squares that I wish I still had. Oh, it's over here. All right, we've got 48. And we want to see if any of these perfect squares are divisible. 48 is divisible by any of those. It's not going to be 49, right? So we'll start with 36. Positive 48 divided by 36. No. 48 divided by 25? No. 48 divided by 16? 3. Good. So the square root of 48 becomes the square root of 16 times 3. I is on the outside. Square root of 16 times 3. What does the square root of 16 mean? That I can call it 4 outside the radical. So 4i square root 3 is the simplified version of negative 48. So 4i square root 3 divided by 2. All right, this is where it gets pretty difficult because you're going to divide all of this by 2. This was difficult, and then simplifying this even further is difficult. What I would do is I would make it negative 2 divided by 2 plus or minus 4i square root 3 divided by 2. Because the negative 2 divided by 2 is just negative 1, right? So x is negative 1 plus or minus 4i divided by 2 is 2i square root 3. So 4i divided by 2 becomes 2i. Negative 2 divided by 2 becomes negative 1. Good. All right, so our final answer is negative 1 plus or minus 2i square root 3. And that is the format they give us for the answer. Negative 1 plus or minus 2i square root 3. Answer in the form a plus or minus bi square root c. And that just tells you how to enter it so that they accept it. Number 40. We can't read it, but it just says solve the equation. 9x squared plus 12x plus 4 equals negative 9. So first step would be to, because this is a quadratic formula answer, right? First step would be to get everything equal to 0. add 9 to both sides so that it is set equal to 0. 9x squared plus 12x plus 13, darn it. Just hoping we would be able to divide something out. So that means A is 9, B is 12, C is 13. Good. X equals negative B, negative 12 plus or minus the square root of 12 squared minus 4 times 9 times 13 all over 2 times 9. And then you'll just work that out. X equals negative 12 plus or minus the square root of 144, right? 144, 4 times 9 times 13. 468. So it's minus 468. 2 times 9 is 18. X equals negative 12 plus or minus the square root of 144 minus 468. Negative 324. Divided by 18. Good. So for 324, it's helpful to have another longer list of perfect squares, or you can do it in your calculator, right? You can make your own list of perfect squares. 324. One times one is 1, 2 times 2 is 4, 9, right? 16, 25, 36, 49, 64, 81, 100. 11 times 11 is 121. 12 times 12 is 144. 13 times 13 is 169. 14 times 14 is 196. 15 times 15 is 225. 16 times 16 is 256. 17 times 17 is 289. But 18 times 18 is 324. You can also just go square root 324 before you start making your list. Those would probably be smart. So you can say negative 324 is negative 12 plus or minus negative 1 times positive 324. The square root of negative 1 is going to change to I, right? And the square root of 324 we just learned is 18. So that's going to actually become x equals negative 12 plus or minus I for that part times 18 for that part divided by 18. Good? Okay, rewrite it again. X equals negative 12 plus or minus 18i, just to put it in the correct order, divided by 18 equals negative 12 over 18 plus or minus, sorry, plus or minus 18i over 18. And that's going to become negative 12 divided by 18. Negative 12 is like negative 2 times a positive 6. And we'll say 18 is a positive 3 times a positive 6 plus or minus 18 divided by 18 is just I, right? A little bit confusing. So that gives us that. Negative 12 gave us negative 2 times positive 6. 18 gave us 3 times 6. Good? Does that make a little more sense? So here I split it into two fractions, this guy and this guy, with the plus and minus between it. That became that became that because that canceled. So now we've got x equals negative 2 times 6 over 3 times 6 plus or minus I. And then also we see that 6's cancel. So that becomes negative 2/3 plus or minus I. All right, for question 42, we have square root of 3y plus 4 equals 4. We have sorry, I'll start over. Question 41, the square root of 3y plus 4 equals 4. We have isolated the radical sign on the left. So now we just need to cancel it. You cancel it by squaring it. Anything I do to the left, I have to do to the right. So 3y plus 4 squared, the square root of 3y plus 4 squared gets rid of that square root, and I have 3y plus 4 equals 4 squared, which is 16. Now I just solve for y. Y is being multiplied by 3 and 4 is being added, so I'll subtract 4. Anything I do to the left, I have to do to the right. 3y equals 12 divided by 3. Y equals 4. Okay. All right, for number 41, what you want to do is isolate the radical on the left. So it'll be just like this one, but first we need to move that negative 4 over to the right side before we square everything. Might still work if you don't, but I find this to be the easiest way. So we have the square root of 4a minus 3 outside of the square root minus 4 equals -1. We'll move that -4 by canceling it. So 4 is being subtracted from a, we'll add 4. Anything I do to the left, I do to the right. Square root 4a minus 3 equals -1 plus 4 is +3. Now, to get rid of that square root, we're going to square it. Anything I do to the left, I have to do to the right. So that just leaves me with 4a minus 3 equals 3 squared is 9. Now, a is being multiplied by 4 and 3 is being subtracted, so I'll just add 3. Anything I do to the one side, I do the other side. 12 equals 4a divided by 4, divided by 4. Those cancel, and I have a equals 12 divided by 4 is 3. Good? Okay. A is 3. Question 43 says, solve the following inequality and answer in interval notation. This you can treat just like if that greater than sign was an equal sign. So we have 30y on the left. Y is being multiplied by 30, and then we're adding 7,600 to it. That is all greater than 15,000. Again, we want y alone. Y is being multiplied by 30, and then 7,600 is being added to it. So we'll do the opposite with this pen. Minus 7,600 on this side. Anything I do to this side, I also have to do to this side. Now we've got 30y. Those cancel, is greater than 15,000 minus 7,600. $7,400. Y is being multiplied by 30. To simplify that, we just divide by 30. Anything I do to the left, I do to the right. Those cancel, and I get y is greater than that 7,400. We're going to divide it by 30. Make sure you get your answer in fraction form. So it's 740 divided by 3. You can also do this on Desmos if you do not have a calculator that you like. So that was 7,400 divided by 30. It'll give you the decimal, but you press this convert to fraction button, and it'll give you the simplest form of the fraction. So our answer is y is greater than 7,740 divided by 30, but answer in interval notation. Okay. Interval notation is we want to say everything greater than 740 over 3. If I picture that on a number line, it doesn't really matter what that number is. It's 246 2/3. But we'll just say it starts there, greater than, right? Greater than means it's going to go in the positive direction forever. Okay? So it doesn't include that, right? It'll just be a parentheses. That means we start at but don't include 740 over 3. Our next number is just an arrow going in the positive direction forever. So we think of that as infinity. Infinity always gets the parentheses, never the bracket. The bracket is for including, and you never include infinity because infinity doesn't have an end that you can include. Okay, so our final answer is open the parentheses, put 740 over 30 as a fraction, put a comma, put the infinity symbol, and then close the parentheses. Good. Okay. Next one, they're asking us to graph the solution. Negative 2x plus 3 is greater than or equal to 11. Remember when we have greater than or equal to, it'll be these symbols. Okay. And then it's parentheses for, but I guess they're asking to graph it, not interval notation. Good. All right, negative 2x plus 3 is greater than or equal to 11. We're going to treat that like an equal sign. X is being multiplied by negative 2 and 3 is being added. So we're just going to do the opposite, which is subtract 3. Put it right into the 11 because those are like terms. I get negative 2x greater than or equal to 11 minus 3 is 8. Now, it's being multiplied by negative 2, so we need to divide by negative 2. Divide by negative 2. Remember, anytime you divide or multiply both sides by a negative to cancel, you flip the sign. So instead of that being a greater than or equal to, that's now a less than or equal to. Very important. Negative 2 divided by negative 2 leaves us with x. X is less than or equal to 8 divided by negative 2 is a negative 4 because a positive divided by negative is a negative. Good. So that's our answer. The way I would describe it is x is less than or equal to negative 4. Here's negative 4. It has an equal sign, and so we know it's going to be either this or this, right? Because it includes. The equal sign means it includes. Less than. Less than means the arrow's going this way, right? So that's what it'll look like when we graph it. It goes up from infinity, but in the negative direction. So from negative infinity to negative 4. It includes negative 4, so we'll use a bracket. Negative infinity never gets a bracket, it only gets a parentheses. So our answer is x is less than or equal to 4, negative 4, apologies. At negative 4, bracket going to the left or in the negative direction forever. Good. All right, guys, I think we're almost done. I think this is our last page. I think this is our last page. Last problem. Can't even read it, but let's see what it says. It says, solve the following continued inequality and graph the solution. Answer using interval notation. This one said answer using inequality notation. So we could use that symbol. This says solve, you can't see it, but answer using interval notation. So we have negative 40 less than 30y minus 40 less than 40. Good? All right. So remember, these are just like equal signs when we're solving for a variable. And instead of 2 sides, now you have 3 sides. You have 1, 2, 3 sides. So anything you do to get y alone, you do over here, here, and here. In this case, y is being multiplied by 30, and then we're subtracting 40 from it. The opposite of subtracting 40 is to add 40. I need to do it to the middle, this side, and this side. Okay? So now we've got negative 40 plus 40 is 0, so we'll write that as 0. Keep that sign the same. We still have a 30y. Those cancel. Keep that sign the same. 40 and 40 is 80. Okay? Don't just ignore this because it's 0. You're still going to have 3 parts when you finish the equation. Okay? Now, y is being multiplied by 30, so we want to divide it by 30. Anything I do to the middle, I'm going to do to the left and to the right. Okay? This is not a negative 30, so those signs remain the same. 30y divided by 30 just leaves us with y in the middle. 0 divided by 30 is just 0 because 0 divided by anything remains 0. 80 divided by 30 is 8/3 if you put it into the calculator, okay? So answer using interval notation and graph. Here is 0, here is positive 8/3. What is happening? There are no equal signs, right? So it's all parentheses. 0 is smaller, so that gets the open parentheses. 8/3 is bigger, so that gets the open, that closes the parentheses. And it's just between 0 and 8/3. No bracket, because it doesn't include 0. There's no equal sign. No bracket, because there's no equal sign for 8/3. And how would we write this in interval notation? I find it easiest to go from graphing to interval notation because I just take those same shapes. That shape started at 0, ends at 8/3, that same shape. So that's my answer. Between 0 and 8 divided by 3. All right, guys, that is all of the full review for exam 1. And I hope you found that helpful. Please email me if you have any questions. Have a good day.